Okay, so in this video, I want to cover SmolLM3. This is a new model that came out today from Hugging Face, actually trained by Hugging Face, created by Hugging Face. It builds on the previous small LMs that they've had in the past, slightly bigger than the other ones at 3B. But in this video, I want to cover not just the model itself. I think it's really interesting around what they've released about how they created this model and the different kinds of training techniques that they've used. And also at the end, I want to basically test it, not just with reasoning and non-reasoning, but also with agentic users. So let's see how it does at things like function calling and stuff like that. Could this be the model that you run locally to run all your agents without having to use any sort of proprietary model, etc.? All right, let's jump in. So Hugging Face has released this new 3B model, and they've released both the base model, an instruct model, and an Onyx version of the model. And already people are making GGUF versions, which you can use on a Llama and LM Studio. But the model itself is certainly impressive. We can see that it lies in this area between the Qwen 3 1.7B and the Qwen 3 4B. And 3B is an interesting size in that it's like a nice size that you could actually run on many mobile devices that are out there now. And sure enough, for that size, it seems to be beating out the old Qwen 2.5 3B and the Llama 3.2B. So if we look at some of the core stats for it, we can see that it's a model that's been trained on 11 trillion tokens, which is a very impressive feat, right? To actually train something for that long. We can see that they're claiming that it's state-of-the-art for all the 3B models and also strongly competing with 4B models. And it's one of these new models that allows you to basically turn on and turn off reasoning. So we've looked at some of these before where you've got some kind of flag that you can turn on thinking or non-thinking. They're claiming that it's multilingual. For me, there's only 6 languages there. They're all European languages. For me personally, that's not very multilingual. But also, interestingly, this can actually use a long context of up to 128K in here. Now, the thing that I find that actually is perhaps more interesting than the model itself is that they've released this blueprint. And this blueprint is exactly how they've done each step of the training. So even with the open weights models from DeepSeek, from Qwen, usually they're quite good in telling us at least roughly what they did, unlike the papers coming out of the proprietary labs, which really aren't giving you any sort of real facts and basically just maybe have some vague clues every now and then. This is actually a full blueprint of exactly what they did for each of the steps, from the pre-training recipe, how they set up the distributed training, how they did the model architecture, right through to things like the long context training and all the post-training recipes for actually putting this together. So if we just go through those quickly, they've got some of these already up on the blog post. But like I said, you've also got the blueprint where you can just come in and actually analyze these things yourself. We can see the long context can go up to 256. I'm not sure how great it's going to be past 128. It can use tools, which I definitely want to look at the end, and we'll test that when we do the code test for this. And we can see that it's got this dual think reasoning system where you can turn the thinking on and off. And if we jump into the blog post, we can just look at some of the key facts in here. So the architecture that they've gone for is actually similar to some of the Llama 3 architectures. If we think way back now, it's been quite a long time since Llama 3 was released. Clearly, the Llama 3 release was a lot more successful than the Llama 4 release. It didn't require Zuckerberg going out and trying to hire as many LLM researchers as possible for doing that. But we can see that in there, they've got the group query attention. Now, the interesting thing is they've got this new thing called Nope, and they're fully citing in here. So my brief understanding of this is using like a causal mask rather than the rotary embeddings, etc. And you can see that even though they've taken certain things from the Llama series, they've also basically looked around and taken ideas from things like Olmo 2, where they talk about removing this weight decay from embedding layers to improve training stability. Now that's interesting and going to be very useful for anyone that does want to try and train one of these small models. And I got to say that looking at their GPU budget for this, they had 384 H100s for 24 days. That's not a crazy amount of GPUs time. So actually, I think That works out to roughly 220,000 plus GPU hours there. And the interesting thing is you can get H100s now. The price of being able to rent them out is going down. So we're looking at something that probably cost a few $100,000 to train. It's certainly not in the large millions of dollars that we've seen people do in the past. All right, so one of the things that is always the mystery of the proprietary models is how do they do their data mixes and how do they do their pre-training? So it's really nice to see here that they're talking about doing a 3-phase pre-training with an annealing sort of at the end of that. But more interestingly, looking at the splits of data as they go through this. So you can see at the start, it's very web heavy for that sort of long phase. But then in phase 2 and phase 3, they actually increase the code, they increase the math quite a lot in there just for this pre-training phase. Now, after that, they talk about how they did the long context stuff and also how they did the actual reasoning stuff. Now, for me, looking at this sort of briefly, it does look like they've heavily relied on both the DeepSeek R1 reasoning traces as well as Qwen 3 for creating synthetic data to be able to make some of these reasoning traces out. So it doesn't look like they've done a large amount of sort of RLVR or anything like that in here, at least in comparison to perhaps some of the Chinese labs that these people are trying to spend longer doing the reinforcement learning with verifiable rewards, etc. Interestingly, they use a new form of alignment in here, which is a variant on DPO. And finally, they also do things like model merging to basically take various checkpoints and try and create a super checkpoint in here. Now, as I mentioned, they've put the base model and the instruction fine-tune model up on Hugging Face. Actually, perhaps would have been nice for them to put up the different checkpoints at the end of each phase of training as well. I'm not sure if perhaps they will release that in the future. That would be really good to see. We can also see that they've also gathered all the data sets here, both for things like SFT, for reasoning data sets that they were using in there. And generally, it seems to me that we've got to think of this as being one of the most open releases that we've seen in quite a while. Okay, so let's jump in the code and see how the model actually performs. Okay, so jumping into the code, we can see that it's really easy to actually set this model up. No surprise, it's been created by Hugging Face. It's going to work with transformers out of the box. It also works with SGLang and with VLLM. But anyway, in here, you can see I've just loaded up the model. If we want to do reasoning outputs, we can just basically pass in a prompt, and you'll see we'll get the standard sort of DeepSeek think tags, where in this case, we've got quite a long think tag going on there, and then we've got the answer coming out. If we want to get it with no reasoning, in the system prompt, we just need to pass in this /nothink in there. And then you'll see that we just get an answer out with no thinking tags, just the final answer out there. All right, so you can manipulate the thinking with the system prompt a bit by referring into it. And the thinking will often be very long. Now, unfortunately, I wasn't able to get it to number the thinking and break it down into sections, which is the same for the DeepSeek ones. With the way that they trained that model and the Qwen 3 model, they're really using this RLVR by verifiable rewards, which doesn't give you a lot of control over that long chain of thought to get to the right answer. You see this being actually different in the Gemini models and some of the other proprietary reasoning models out there, which kind of sectionize their thinking tokens as they go through. Anyway, here we can see that, okay, it did a nice long think, and then it gave us quite a detailed response out here. Now, if we look at sometimes like this, so this is a code generation one, it will just generate empty thinking. So I found this on a few sort of examples. I'm not sure, what they expected behavior is for this. Maybe if we'd asked some things before we actually sent in the Python function definition, we would have got a better response out. So I do notice this for a number of responses where you will get empty thinking out there. I got to say, though, for such a small model, the thinking turns out to be quite good. I can't help but feel that perhaps it's just fine-tuned in from DeepSeek and Qwen 3 as opposed to actually getting the model to do thinking itself. It's just extended chain of thought. But that said, we can look at, so a question like this, write a detailed breakdown of building a successful lemonade stand. The thinking actually is quite good, right? It goes through the different elements before giving a detailed plan out for this. Now, when we compare this to a version with no thinking, you can see in this case, the plan is much simpler, definitely not as well thought out and stuff like that. So it does show that the thinking will help for certain kind of responses. Often you will also get the model wanting to give some justification at the end or to give, so in this case, additional tips at the end. Okay, another one, old question, what is the difference between llama, vicuña, alpaca? Again, here it just dropped out the thinking. I'm not sure why, but it gave us a very detailed sort of response, probably on par with some of the models that we've seen before. Now, one area where I thought it was a bit not so great, here where I've asked it, what is the capital of England? I've left the thinking on. We get a huge amount of thinking, and then we get a step-by-step breakdown of the answer, like the justification that I was talking about before. Another example here of the thinking for the Geoffrey Hinton question, gives some nice rationale at the end for this, does really well on the GSM 8K stuff, not surprisingly now. It is kind of amazing to think that a 3B model is doing so much better on this kind of stuff compared to going back a year, 18 months ago, where we were looking at 14B models that couldn't do a lot of these things. All right, finally, just to finish up, the tool use. So one of the things that I find most interesting about this model is that it can do function calling and that it's supposedly been primed a bit for agentic use. So when we come in and look at the tool use, we can basically just define a tool. You can see here that we've just defined the schema for the tool in here. We can then pass in a message. And sure enough, what it will do is that the message, this is showing all the data that's coming out. Sure enough, the message will actually then include a tool call in it. So in this case, the tool call is the get weather, and it worked out that it was Copenhagen, which is what it should have been for this. So I tried this out for a number of different functions. So doing like a search thing where we can say, okay, when will OpenAI release their open weights model? What are the rumors? And we can see, sure enough, we're taking in that one tool there, and it's got some instructions of how to do it. And sure enough, it returns back a tool call. So the tool call in this case is the search web. And the arguments it's come up with is OpenAI, open weights model, release date, rumors. So it actually is working out what are the keywords. So I tried this for a few different things, for things like, okay, who won the Nobel Prize in chemistry? Now, technically, if its cutoff date is June 2025, it should actually know that. But in this case, it decided, okay, let's do a search, 24 Nobel Prize chemistry winner. I actually think that's good, right? That I don't expect a 3B model to be really good with facts. I feel it's like better for it to actually try things out there. All right. And then finally, if we're passing in multiple tools, here I've got the search web and the weather, and we ask it something that really shouldn't use either tool. We want it to not use a tool, right? We want it to know that, okay, it should just respond to this. Now, I have mixed responses with this. Sometimes it works really well, as you see here, where, okay, we've passed in the tools, we've passed in something, we didn't get a cool call back, we didn't get any thinking, we just got, I'm an AI, I don't have feelings, but I'm here to help. We got a response back. Often it would be like this. Every now and then I found that, okay, it will try to use the search tool for things that perhaps maybe you don't want it to use the search tool. Now that could also be down to my description. In here, I've got allows you to use the search the internet, find useful and up-to-date information. You could play around with that. And I think you certainly want to do that if you're planning on using this thing. So the model is out also on Llama. I think this is a custom version someone's uploaded, but my guess is we'll see probably an official version up there as well. And I'm sure it's just a matter of time before you see it on LM Studio as well. Overall, this is a really interesting release from Hugging Face, and I really think they should be commended for this. They've not only released an interesting model, but they've also released this really nice blueprint of how they created it, what they did at each step. My guess is that there's probably a full paper coming with maybe even more details, which will be great. Hopefully they will release the checkpoints for like each of the phases and stuff like that, so people could look at testing different ideas. For example, if you wanted to change something in the phase 2, you don't want to have to do the whole phase 1 by yourself. If you could just take their checkpoint for that and then try out new ideas for the phase 2, phase 3, or for the different sections of the post-training stuff as well. There's quite a lot of tokens that they trained on in there. Anyway, check it out. Let me know in the comments, are you actually still looking to use small local models on your own machine, or are you more moving to the really cheap proprietary models that can do all of these things? This is certainly one of the things I'm looking at more and more, and talking to other people, I see use cases for sort of both systems and stuff. So I'd love to hear your thoughts about that in the comments. Anyway, as always, if you found the video useful, please click like and subscribe, and I will talk to you in the next video. Bye for now.